Throughout this integrated range management class, we've talked about the effects of grazing on fire on many aspects of landscapes. Today we're going to focus specifically on watersheds and hydrology and the effects specifically of grazing, and we'll try to add as much fire as I can. Okay, just some terminology we got to get right. Of course, I suspect most of you know what a watershed is. We will talk about tributaries, some sub-basins. We'll talk a bit about slope and divides and also the relationship between the watershed and the groundwater. But what is the definition of a watershed? Well, book definition of a watershed, it is a surface water designation. It's all the area that flows into a distinct drainage. That's kind of the book definition. Those distinct drainages would be streams, rivers, creeks, ponds, anything that is a surface water designation. The separation between watersheds then are those ridge tops, and those are called divides, like the Great Divide between that is the Rocky Mountains between the eastern and western U.S. Those are divides. I'm going to generally talk about watersheds, but remember, watersheds are just one piece in a long scale. The very largest watersheds would be called river basins, in the U.S. like the Mississippi River Basin or the Columbia River Basin, all the way down to little streams or some sub-watersheds. Watersheds are identified by scientists and managers by what we call HUCs, Hydrologic Unit Codes. So here's some definitions of HUCs. There is a database that I've got linked here through the USGS that shows you more about these HUCs, and you can even get you can download GIS layers for them if you're interested. But at the largest level, that river basin level, they recognize 18 HUCs here. So you can see like 16 is the Great Basin, 17 is Pacific Northwest, 10 is the Great Plains and the Missouri River Basin, etc. So these are large river basins. And then on the right-hand side, I have a lower code of HUCs, or Hydrologic Unit Codes, or watersheds in Idaho. And I guess you can see that the more level the terrain and the less the precipitation, the larger the HUC. So in the middle of what they call the Great Desert of Idaho is that large HUC that is just a large area of fairly flat ground in that sort of Arco area of Idaho. And then what's really black up in the mountains, those are really rough territories. So just an idea of what HUCs look like in a geographic sense. One of the most well-researched HUCs in the nation is in Idaho, and that's the Reynolds Creek Experimental Watershed. I'm going to talk a little bit about some research that came from Reynolds Creek, so I thought I'd introduce it here. This is an area that's southeast of Boise and southwest of Boise, and its highest regions are the south, and then it flows to the north at the lower regions of the landscape. So those red regions on this map is the lowest elevation, up to the blue regions, which are the highest elevation. We've talked a bit about ecosystem services in this class, and certainly you probably know what ecosystem services are, but if you think about watersheds in the context of ecosystem services, they do a lot. So you can think of watershed services as things like regulating climate, providing shade and shelter, preventing soil erosion, maintaining soil fertility and health, maintaining a healthy watershed balance in terms of streams and river flow, and then infiltration and water filtration, removing sediments from water before it goes into rivers, and then finally that regulation of river flows and groundwater levels. All of those things happen as services of the watershed. When we manage watersheds, we're affecting all of those and many more services. I'm going to break the major services we'll talk about in this discussion into two categories. One are those hydrologic functions, water capture. How does all the water in the landscape get captured and moved into the soil? Water storage in the soil, and then water release into streams and rivers and ponds. The ecological function is also important, providing a diversity of sites specifically for biogeochemical reactions, the nitrogen cycle, the carbon cycle, etc., and then providing habitat for plants and animals in streams and in the watershed basin. So how does grazing affect watersheds? Well, at the minimum, grazing animals are herbivores, so that there's this effect of herbivory, and it affects the plant regrowth. It removes dead biomass, and it reduces the amount of herbaceous biomass, especially that remains in the landscape, which affects hydrologic function. Grazing animals also have a trampling effect, which can have both beneficial and detrimental effects on the landscape. We'll talk about those. Soil impacts, compaction, for example, from grazing animals, but that can also create seedbed opportunities. So as animals trample soils into the landscape, that can be a seedbed preparation factor. We do know that livestock affect biodiversity. I'm going to focus specifically on weeds. They can control weeds and invasive species through targeted grazing or well-managed grazing, or they can introduce weeds and promote weeds and invasive plants in a landscape. The number of weeds in a landscape is important because often these are annual plants that hold the soil less well than perennials. But there are cases where invasive plants are really good hydrologically in terms of keeping water in the landscape. So it's really a bit species dependent. And finally, always remember that livestock don't occur on landscapes without humans, that there are many management actions of range managers that affect the hydrology, such as creating water storage around streams or seeps and springs, and then our actions such as prescribed fire, which change landscapes and watersheds. A little bit about water classification. We're going to talk mostly about surface water and overland flow in a watershed context, but we'll also talk a little bit about underground water as it affects aquifers and recharge zones. So that's coming. Okay, now you said you knew what the watersheds were, and the hydrologic cycle is at the root of watersheds. Surely somewhere in your education you had to determine the different aspects of the hydrologic cycle, how water flows through land and affects land systems. So take a look at this. Can you fill in the boxes? Well, it's easier than you might think, because several of these boxes are indicating the same factor. At the top we have precipitation. That's accumulation and movement of water out of the atmosphere into the land. And then there's what we call evapotranspiration, evaporation that occurs from plants, from soil, and from water, and then the transpiration of water out of leaves as leaves lose water during transpiration. Once you get to the water surface, water can be either absorbed by roots or it can infiltrate down to the soil. Infiltration is when water moves from above the soil into the soil. Inner flow is the movement of water throughout the soil, and then it can move to the surface water system through seeps and springs. Deep drainage is when water moves out of the reach of plants in the hydrologic cycle and in that top layer of soil. Okay, so those terminologies. Precipitation, you probably know what it is. It's accumulation of water vapor into raindrops, snow, or hail. Interception is when precipitation strikes an object such as vegetation, litter, rocks, and eventually it gets into the soil, but not necessarily. Oftentimes it will hit that vegetation layer especially, or the litter layer, and it will evaporate right back into the atmosphere. Infiltration is the movement of water from the atmosphere into the soil, or from plants into the soil. And then percolation is the movement of water through the soil up to deep drainage. Capture is actually the amount of water that is captured by the landscape and is held on the landscape, and it's dependent on the type of vegetation, the type of soil, the amount of land cover, mostly by vegetation, but rocks and other material. And then, of course, it's affected by the storm intensity. This picture here on the right is apparently a very intense storm that caused a lot of runoff. As we think about water capture in a landscape, let's turn our attention first to infiltration rate. This was a study done in Texas in 3 different community types, a live oak motte, and then they had a bunchgrass site that was mostly Cytodes grama, and then a sodgrass site which was curly mesquite, Hilaria belangeri. So what they did was they had a simulated rainfall event, so they had sprinklers on top of these habitats, and they very carefully measured the amount put on and the amount that ran off. And infiltration rate was the difference between the rain and the amount that ran off. So what you can see here is they applied 203 millimeters per hour of rain, and the oak motte had nearly 100% infiltration. There was very little runoff, so nearly all of it went into the soil. The bunch grass started out by having very high infiltration rate, but as the soil became saturated and the pores in the soil kind of became clogged, the amount of water running into the soil reduced and the runoff increased. Sodgrass was even more accentuated. It started out fairly high, but then as the rain continued over the 50 minutes, more and more runoff occurred and less infiltration occurred. When you read the study, there's a couple of important things. The oak motte had very high biomass production, but also organic matter in the soil and at the soil surface. The bunchgrass had the next greatest level of amount of water at the soil. Amount of biomass at the soil surface and in the soil, and then the sodgrass had the least. So the authors attribute most of this difference in infiltration to the amount of vegetation and litter at the soil surface and in the soil itself, the organic matter in the soil. Infiltration also depends on aggregation of the soil particles and porosity, because if the soils have a lot of organic matter and a lot of space between particles, infiltration rate will be fairly high. The biggest effect here that we can have in management is the amount of organic matter in the soil and the trampling. And one thing that we've said when we talked about riparian areas is that we have to be careful, especially in the spring, because the soils are wet, and trampling can really break that aggregation in the soil and make the soil very dense so that it doesn't have very good infiltration, so it can compact the soil. And this is just a kind of a diagram that shows you how important those spaces between particles are. In the same study in Texas by Thoreau and colleagues, they looked at what happened to the water, the precipitation when it hit the landscape. So in that oak motte on the left-hand side, that oak brush stand, this was live oak, a lot of the water, 7% of it, actually intercepted by the shrubs. There was very little inter-reel erosion at the soil surface, no soil runoff, so the water was completely captured, and a great deal of infiltration. The landscape that was the bunchgrass type also had very high infiltration, 75.5%. A little bit of movement across the soil surface, that's inter-reel erosion, movement of soil between plants essentially, and there was less interception. But basically those two types had really high interception. When you got to this fairly open landscape that was a sodgrass, first of all, there's very little interception. There's a lot of movement of soil across the landscape, and whenever you had that movement of soil and inter-reel erosion, there was also more surface runoff and less infiltration. And then finally, the most erosion and surface runoff and least infiltration happened on the bare ground site with no interception by vegetation or rocks or anything else. So that's just the level of difference that we can expect in infiltration and runoff due to different types of canopies on the landscape. And we know from previous lectures that grazing can influence those, and certainly fire can influence the type of vegetation on the landscape. Going from, for example, it could go from oak motte to bare ground in a matter of seconds. How does vegetation affect this transit of water through the system? Well, the first thing is that vegetation affects the litter accumulation. Grazing affects the litter accumulation. Litter is very important because it slows runoff. It decreases the droplet impact. Grazing also affects the amount of biomass. The less biomass you have, the more runoff, the less interception, and the more droplet impact you have. And then finally, because grazing affects both the organic matter above the soil and the roots in the soil organic matter is influenced by grazing. And that's really important because soil organic matter influences the holding capacity of soil and infiltration. An interesting study, I told you there was some work at the Reynolds Creek watershed here in southeast Idaho. What they did is they looked at a study in the sagebrush steppe using rain simulators, and they looked at the runoff within a landscape within the first hour after a precipitation event. and they had a burned site, so that's the dark bar on the top, and they had several unburned sites. The dotted landscape included all of the unburned sites, including those that had no runoff, and then the hashed line is those that had some runoff. So that hashed line, the dotted line is probably a more relevant one because at least we know it had runoff in the average. So I'm going to compare that dark line and the dashed line. So you had a rain event, and within 10 minutes you had runoff. Certainly much higher runoff on the burned area where there was no vegetation than on the area where there's some vegetation. So twice as much runoff on that landscape. And then over time, the amount of water that was running off in the system did decrease just because water started to infiltrate and less water was being administered in the event. But no doubt, when a landscape experiences fire, one of the things we have to worry about is runoff from a rain that might occur after the fire. Other things that influence the amount of water that is actually stored in the watershed. This term surface detention may not be familiar. Detention is the amount of micro relief right at that soil surface. It's affected by vegetation, topography, and litter. And if you have that real micro relief, the water is slowed and infiltration increases. It's also affected by the slope, the soil texture, the soil structure, and the soil depth. But we can manage surface detention because we can affect livestock impact through compaction and hoof action, and we can also affect the kind of vegetation on the soil surface. The upper surface of the groundwater level is called the water table. So when you say it's 50 feet to the water table, you're saying that you got to go through 50 feet of soil before you hit that upper surface of the groundwater. And as we move into discussion about water storage, it's important to think about water tables as being that area that we're trying to build up. When you have a really large body of water that is an impermeable layer way down in the soil, that's the aquifer. So when we tap in and start a well, we're tapping into the aquifer. I used to think of it as just like a lake underground, but it's really just a layer of impermeable rock that holds water. And when we drill into that, then we have water accessible. When we add water to the water table or the aquifer, we call that recharge. So in range management, we talk about recharge zones and aquifer unit or areas that we're affecting an aquifer, so a recharge zone. And we can affect these by constructing water storage areas such as reservoirs. But let's think mostly about how we affect that recharge zone. Okay, one of the ways we affect recharge is by trying to keep water on the landscape. And on the bottom we have a graph that shows if you had a healthy watershed and you were really keeping water on a landscape after a rain event, you would have a rain event, you would see an increase in the stream flow, but it wouldn't be a very high peak, and it would take a long time for that peak to happen. So it would take several hours or days after the rain event before you saw the peak in the stream flow. That means that a lot of the water is being held in the watershed. If you're not doing a good job with management and you have a degraded watershed, then you have a rain event, you have a very quick peak of stream flow, and most of the water runs off of the landscape. So high surface runoff, a lot of inner flow between the surface horizontally, and not a lot captured in the springs and seeps, but the water can flow into the upper surface and then become springs and seeps. But the problem is that you're not adding a lot to the recharge zone if it's going into that stream right after the run event. So other ways that water is released in the landscape: evapotranspiration. That includes both transpiration and evaporation. Transpiration is that water loss from the plants during respiration. It's important to plants for the cooling event that occurs, keeps the plant cool. And then evaporation is the loss of water by heat. Could happen on the vegetation surface or on rocks or on soil or even on water. The reason we often put those together is because it's really hard to separate them out in nature, how much was lost from evaporation and how much was lost from transpiration. So on some really careful studies, of hydrology, they will separate the two, but often we just talk about them as evapotranspiration, or loss of water from the soil surface before the water gets into the soil and it is infiltrated. Again, now thinking about trying to keep water on the landscape as opposed to moving it down into deep drainage and into the water table. Deep drainage is the loss of water below the root surface, and if you have low bulk density because of trampling, you can decrease deep drainage. So you want to keep the water moving through the soil into the landscape. Generally, you want to keep it the root zone, but as it moves down into the water table, you can affect it with grazing or fire. Any factor that affects or decreases infiltration will likely decrease deep drainage and will decrease the amount of water that actually ends up in the water table. So some summary points. Impacts of runoff and infiltration. Water inflow, the amount of water that comes into the system, is generally little affected by management practices. It's really hard to increase precipitation, as you know. So overgrazing can, however, decrease biomass in litter, which increases albedo, or the reflection of sun and the evaporation of water, and that could decrease the convection precipitation events. So it decreases those afternoon showers, etc., if you have that more reflection. So that's one way overgrazing can influence precipitation. Another way overgrazing can increase infiltration is because it can decrease airborne bacteria, which decreases water precipitation and formation, a droplet formation, and then it decreases precipitation. So this whole idea that once you get into a drought cycle, it's hard to get out, that's because you get into a situation where you're not having enough water in the atmosphere and you don't have the materials in the atmosphere to create raindrops. Okay, so it's very interesting, but in the large scheme of things, grazing does not have a huge effect on precipitation patterns, although it could influence sort of local precipitation patterns. Interception, then, is when water is intercepted by the vegetation. So grasses intercept 10 to 20% or a bit less of the rain that hits landscapes. Deciduous trees and shrubs have higher levels of interception, 20 to 50%, when they have leaves on them, in the case of deciduous trees. Evergreen trees, on the other hand, can intercept nearly 100% of the vegetation, which is what happens under juniper trees. Really high interception. I remember 10 or 20 years ago, we used to think that the reason there was no vegetation under juniper trees was because the junipers were somehow exuding some chemical that prohibited growth, an allelochemical effect under the tree, and it prohibited growth of other plants. And it turns out the only reason there's not many plants under a juniper tree is because very little water ever makes it into the soil under a juniper tree. It's intercepted in the canopy, and then it just evaporates out from the canopy. Grazing and fire both affect watershed level processes. Wildfires are important, and it's really important to consider the appropriate rest following the fire, because we know we need to have rest after a fire to regain the amount of vegetation, the basal area of vegetation on the landscape, and that's important to increase infiltration. We also talked about the effect of wildfires and the interaction with grazing, in that grazing could affect invasive plants, could control or introduce invasive plants. And then finally, we know that we can use hoof action to break up hydrophobic soils after fire and prepare the landscape for new seeds. Not all soils have this hydrophobic condition, and certainly not all fires create hydrophobic conditions, but when they do occur, hoof action might be one way to break up that soil surface and get water flowing into the soil again. Pay attention, though, because the one real problem after fires is that really high potential erosion that we discussed earlier. The effects of prescribed burning can be similar to wildfire, but usually at a lower intensity. Let's talk a little bit about infiltration. It depends on how the grazing effects, what grazing effects occur on the landscape. Grazing can affect aggregation. It can affect soil density or compaction, and then it can also affect the standing crop or the standing biomass and the litter. Here's an interesting study, old study done by Turner in Colorado in a salt desert shrub. And it just makes really clear that grazing does affect the amount of litter and perennial plants on the landscape, and also that rest has an effect. So over 10 years, from 53 to 63, they had some grazed range and they compared it to some exclosures. And what you find is that over those 10 years, litter and moss decreased in the grazed area where it stayed the same in the non-grazed area. The amount of perennial plants stayed roughly the same. They had a small decrease in the grazed area, and it was a significant decrease, where in the non-grazed area there also was a decrease in perennial plants. So that was probably due to some climatic change, and it also just emphasizes why when you're going to do grazing studies you have to have exclosures or non-grazed treatments at all. Shrub crowns went down. In this case, this was sheep grazing in the salt desert, so we had lower amount of shrubs, whereas in the non-grazed site the shrub cover increased a little, but not significantly. Ground cover decreased in the grazed range and not in the ungrazed range. So big difference, less moss in the grazed sites and less ground cover, and we know that those two things can influence the hydrologic cycle. Oftentimes we hear about this trampling effect or herd effect. Some people think it's very good that we need a herd effect to break up the soil and kind of rejuvenate the system, reset the clock. Other people say it's very damaging and it compacts the soil, and it can be very damaging to the hydrologic cycle. Well, the truth is it can have both positive or negative effects. Let's go to those effects. Yes, hoof action or herd effect can compact soil, or it can break up the soil aggregates at the soil surface and reduce infiltration. It does depend on the soil type, the grazing intensity, and the climatic conditions. In some cases it can enhance germination because it incorporates seeds into the soil, and then other times it decreases infiltration. It's really important to pay attention to how it disturbs biotic or biotic crusts or cryptogamic crusts at the soil surface. It can increase infiltration in some areas. In some areas the biotic crust can be so thick that it prohibits water from growing into the soil. But usually, especially in the West, we don't have those kind of biotic crusts. Usually biotic crusts are beneficial. They increase infiltration, and disturbing those biotic crusts decreases infiltration. So it is site dependent. Most of the hoof action in the West tends to be detrimental. It tends to compact soil, and it tends to remove biotic crusts, which increase infiltration. So surface detention is that roughness of the soil surface. It does depend on the soil intensity and the soil moisture levels. Grazing can increase surface detention and micro-relief, so that can be good, but very heavy intensities, especially on dry soils, can really decrease micro-relief, which tends to be bad. There have been some pretty good studies of how grazing intensity affects the trampling influence, and here was a study done in Texas where they had trampled dry soils and trampled wet soils at a moderate level, which was 1x, twice the moderate level at 2x, and 3 times the moderate level at 3x, compared to no grazing, a 0 level of stocking intensity. And whether you're looking at infiltration rate or interior erosion, what you can see is as you increase the stocking rate, you tend to decrease infiltration and increase interior erosion. The biggest difference is if you compare the wet to the dry on either of those levels, and you can see that this is why it's so much more, the compaction is so much more dangerous on the wet soils than on dry soils. So where you may have very little impact of intensity on dry soils, you have really huge impacts on the wet soils. So in summary then, vegetation impacts, anytime you decrease cover, you decrease interception and you increase droplet impact, which increases erosion generally. Anytime you decrease above ground biomass with fire or grazing, you decrease organic matter and you decrease the soil aggregation generally. If you decrease the below ground biomass, then you also decrease soil aggregation and you decrease percolation down into the soil. If you have a type conversion from a herbaceous soil to a woody soil, that greatly affects interception and infiltration rates. So all of those factors can be influenced by grazing and fire. So that's what you need to pay attention to when you prescribe a treatment that's going to have a watershed effect. What's the effective stocking rate? Well, it really depends on the vegetation type. Ungrazed areas generally have higher infiltration rate than grazed plots. Moderate or light grazing intensity can be very similar, and you don't seem to have effects on infiltration until you have really excessive grazing levels. Heavy grazing can also cause a reduction in infiltration rates because of compaction and because of a reduction in surface detention. So as a summary figure, this was proposed in a book that Texas A&M put out years ago about the effects of grazing on landscapes. And this graph is pretty clear. If you're at a level where you're at an equilibrium of soil from formation and erosion, you're at some sustainable level. If you decrease grazing, in many places you would increase cover and soil organic matter. That would enhance soil structure, which would increase soil infiltration rate, which would increase cover in our soil organic matter, which would increase infiltration rate, which would increase soil organic matter, up until some level at which the soil cover is so high that new plants can't grow. I mean, the soil cover by existing plants or litter is so high, there's a mat at the soil surface that new plants can't come up. So then you probably reach some new equilibrium. The downside of this, or the level of grazing that increases desertification or causes desertification, is on the right side. So you're at an equilibrium, you increase grazing intensity, that means you decrease cover and soil organic matter, which decreases soil structure, which decreases infiltration, which decreases soil cover and organic matter, which causes deterioration of soil structure, which increases infiltration, which decreases cover and soil organic matter, and on and on and on and on, until you go from an area that has vegetative cover into a desert. So this bottom side of this chart is what we would describe as desertification. We talked a lot about grazing and fire. Don't forget there's a lot of human needs, desires, and influences on watersheds. We do want clean water. We use watersheds as a food supply through grazing animals, but also through aquatic animals. We use them for recreation. We enjoy riparian areas and watersheds for wildlife. Really, the flood protection effects are really important on watersheds, and many, many, many more things that we require and ask of watersheds. So our ability to manage those watersheds is really important. Just remember, it's not just grazing. So in conclusion, what happens at the top of the watershed is going to affect things that happen at the bottom. That's why we see groups like watershed protection groups and watershed management areas, because effects are united or connected in a watershed. Proper grazing management is critical to maintain the function and services, including keeping your eye on interception, infiltration, and recharge in the watershed. And finally, the watershed is a complicated area with many interactions, spatially and temporally in the landscape. So it's a great challenge, but it is a challenge. So those are some basics about managing watersheds and what to keep your eye on if you're in charge of managing watershed for water quality or water output.